So welcome to the LTX vendor session. I think we got half an hour of updates, what's new uh, with the software we care about. I think we don't want to sell a platform to you. Some people like to sell platforms. I think for us, the platform is more or less Modelica and FMI. That's our platform. And we try as LTX to be more or less the lubricant between these building blocks to build nice solutions by it. So our driver is to support the transformation to sustainable energy systems, more or less make Modelica work for end users. And I got 5 bullet points today. So the first one is Daimler. I don't want to talk a lot about Daimler because I'm in a funny order before that. So I don't talk about Daimler much, but we are selling Daimler in Germany, Austria, and Switzerland. So for the local people here, they can buy Daimler from us. And Daimler is for us our Modelica, FMI, and more SSP workhorse. Yeah, and I'll show a bit what we do for our customers. The second thing, we are not really sure, is it a tool or a service, is our resim tool. So this is more or less a Python tool chain we built over the last years to do regression testing for multiple Modelica tools and FMI tools. So there's our special role. Okay, we sell Daimler, but our customers more and more use multiple Modelica tools and have to make sure that their stuff works in multiple tools. And now the first proof of the pudding for this tool this year, thanks to Francesco, was that we started to do nightly tests during the development of MSL 4.1.0, and we're discussing whether to proceed with it or not. Okay, so that's more general Modelica stuff, and then we dig a bit into libraries. So we partner a lot with TLK, so that's the Leo, TLK, and Exergy. These are the 3 founders, more or less, of LTX. So from TLK, we do have the TIL library we're talking about, and the add-ons then for all the hydrogen and power to X processes. So there are 2 libraries currently, the TIL add-on for hydrogen and the process systems library from TLK Energy in Aachen, and the hydrogen library from Dassault, another one. So you see a lot of movement on the hydrogen side, and so I'll try to give a bit of insight what we're doing there. And then only 3 sites news on the DLR visualization library, just as the last stuff. So I won't do a company introduction, just we happen to be 10 years old last year, and a bit of history here. We are Daimler distributor in the German-speaking market since 2015. We had our first research project then in 2016. We started close collaboration with BMW in 2017 and carrying on this for a longer time now. Then at some point, Sonia, who is unfortunately ill today, but she had to start the Modelica Association back office. So we like a little service provider for Modelica Association, more research projects. And now we are in the year 2025. I got just some numbers for we are very little, only 7 people. We have about 2,000 users out there in 60 companies, 15 research institutes, and about 90 university institutes. And I think this is a main driver for us. We try to get it to universities that people drop out of university which already know this stuff. We do as far as we can do as a little company. Yeah. Okay. First, Daimler, I had a subtitle here. For me, Daimler is a steady evolution. You know, I use Daimler since I was a little kid, and I had to install it from floppy disks. So then back then I couldn't use it, but since then I know it. And for me, it's always improving year by year. And I won't go into the details. I just have 3 slides how we try to help our German-speaking customers to really keep track. So that's stuff, examples which happened since the last Modelica conference. For example, Daimler generates more efficient code for Modelica functions. This is in the release notes of Daimler, and then we sit down and try it with different libraries for our customers and also with customer models to see, okay, for thermofluid stream, it's 35% more, but some of them get slower. And so some of our customers always ask us, can you try with the newest version, with the beta version, to really see what these new features bring? But more or less, Daimler always has new features which need to be looked into in detail and are usually upfront the Modelica tools. The same now, you can change the size of arrays in Daimler now after translation. So I think there's much more to come. Dasu is talking about an open scaling project. But there's also something, it came about in Daimler 2025X. You could change the size of the arrays, but it was a static limit of allocated memory. Now, the newest version removed this, you have dynamic allocation. So we always try to keep track and tell our customer, okay, now you can do that, now you can do that, more or less. And the last one is, there is now this little optimization GUI, which makes it much more easier to start optimizations from Daimler. But now our customers have to build all their testers to allow component optimization fitting stuff, right? And we try to assist them with building the right optimization setup for Daimler. Okay. So now I stop talking about Daimler because Dasu will talk about the two FMI features in Daimler, because in many cases Daimler is seen as an FMI exporter. Many users in Simulink or Python or something use the Daimler FMUs, but we see more and more that people also import FMUs to Daimler and use it as a co-simulation tool, more or less, with some Modelica to it maybe. And there are, on the exporting side, I think one important feature which came since the last Modelica conference, that's the input smoother, which prevents reset of the integrator step within the FMU, but it's not that easy to use. You have to look into the details because you are introducing a delay and you have to check whether it's good to use or not, but it's a very powerful feature if your co-simulation FMU doesn't have to reset the integrator at each communication interval internally. Now, if you're importing FMUs, you do have variable communication interval. You can change your communication interval with the FMU in Daimler, but you have to know how to do it, to write the right sample equations, and then you can change your communication interval. So it's also a bit hard to learn, but if you do it right, I think Daimler is one of the most powerful FMI integration tools, which you don't see at first sight. You think, okay, it's a specialist tool for Modelica development. Okay. Next thing is our resim. I think the main focus is multi-tool testing for our customers nowadays. So if they use multiple Modelica tools, or if they build FMUs from their Modelica models, they need something where to do all the testing that they get the same results. But the interesting part is everyone talks about result regressions, but at the same time, you always talk about performance, meaning numeric robustness and speed. So it's more or less three things. It should be robust, it should be fast, and it should give the same results. And looking at all three of them is really cumbersome. So we try to help. And maybe I show a quick one for the Modelica standard library to give you an example. So if you go to msl.ltx.de, thanks to Matthias who built it, who's sitting up there, it's just the start for the library project now to do multi-tool testing every night, but more or less we have a reference test run. This is the test set of reference results the project agreed on. So some library officer checked it and said, these are good. And then we do a test run in Daimler and we do a test run in Open Modelica and see how many work. So you see, hopefully all of them simulate in Daimler, and nearly all of them simulate in OpenModelica. And starting the simulation is easy, but the hard part is, if it doesn't work, to figure out what the tools do differently. That's the hard part. And I will give one example. So if you go to one of these reports, in Daimler it worked, you have a long list of models. Maybe we take the pumping system from the fluid library. Many of you maybe know this example. And then we parse all the logs. For example, we say, okay, there are 3 nonlinear equation systems, and the largest one has size 1. And then you can pick out the same from OpenModelica. I already opened the report, and it has 6 nonlinear equation system, and the largest one is 2. So you know already, okay, in the iteration variable there's a difference. Probably if the results are different, maybe it's because of that. At least you can have a look and start going into it. And from my experience in doing this in different Modelica tools is cumbersome, because there is no standard how to find out all these numbers. You have to get it out of the logs and then compare it. And with each version of the tools, maybe the logs change, and you know this. So that's what we try to do with this tool. Okay, and then of course there's result comparison, and you can see which of the results fit together and whatnot. So most of the time we just use the CSV compare tool. So what I'm searching here now at the conference is more or less, this is a lot of work, and we don't want to send all the invoices to the Modelica Association. We need something for the standard library, but I would be interested in industrial users or researchers who want to use that in a multi-tool environment and want to try it out or talk to us if we can do performance tests. One example from, it's quite old, it's a slide from Daimler 2022X, but one example is many customers ask, should I change the C compiler? And then we say, yeah, no one knows. There are many C compilers. So then we do larger runs with full libraries and compare the performance at compile time. Like in this case, it was Visual Studio 2013 as the 1 mark. And then you see, okay, some of them are slower, some of them are a bit faster, and then at simulation, maybe it's like 20%, 15% in the best case, which you can gain or lose by changing the C compiler. But there are so many steps which can go wrong, especially in large corporations with virtual machines and virus scanners and stuff. So you have to run this 10 times and find out, maybe I can trust the result now, and no one wants to do that by hand. So to lay the basics, we also have a Daimler-specific performance workshop where we go through the basics more or less for what can influence the performance, and then you can start to use a tool and start analyzing the performance. Okay. Next thing was the TIL suite. So many of you know probably TIL library from TLK, and we are a distributor in the German-speaking market for it. And it's more or less started out with modeling and simulation of thermal systems. It has a large history of nearly started in the Modelica world nearly 20 years ago. Many larger companies are using it. We just want to give you some overview and some news on the hydrogen side then for today. So the interesting part compared to Modelica Fluid is that you do have the TIL base library, which contains the models, and then you got TIL media as external data and external library. And interestingly enough, the TIL media can be used by other Modelica libraries. For example, the thermofluid stream from DLR, you can use TIL media as well. It's a bit like the Modelica standard library with maintenance. Once it's in, you cannot take it out. So the TIL base library is rather small. It's still a big library, but it's rather small. And then there are many add-on libraries to it to add application-specific features which might not be end up in the base library. So for heat storages, for special heat exchangers, for automotive applications, for adsorption. I mean, if you're interested in adsorption, drying or something, you need this add-on, but it's not needed in the base library. And my experience is there, you have to talk to TLK more or less and ask questions. Is there a model around? Is there an add-on around? It's not like a fully fledged product. I think TIL is a fully fledged product. You can just start using it. But if you're seeking for special models, you should talk to us or to TLK to find out if there are better or newer alternatives. So quick recap of TIL features which came in since the last Modelica conference. With 2024.1, there was a change that more or less all the geometry specification is now variable. So the parameter attribute is just crossed out. So you can dynamically change the size of heat exchangers and can use this for optimization of sizing more or less. And there's also improved geometry calculation in the plate heat exchangers. In 2025.1, there are more motor models because usually you were quite focused on the thermofluid cycle, but more or less you need the electrical drive with it and all the losses of it. And more heat pumps are moving to propane, so there's a full example of a propane heat pump with a hot water storage doing the performance testing as required in the norms. So on the right-hand side, you see the storage model and the heat pump model. Now, the upcoming release now in October, there will be new, more or less example data for screw and rolling piston compressors. And there's a new model if you have applications where the oil, so a lot of the refrigerant is dissolved in the oil, then you can suck this out more or less in the oil to have the right filling level in your system. I mean, there's still, you're doing simulation with pure refrigerant, but you can take into account how much refrigerant will go into the oil to get the right filling mass. There are regular webinars on the new features of TIL, so the best way is to follow TLK Thermo on LinkedIn, and then you will see the new webinars for it. Now, I said it earlier on the optimization graphical user interface in Daimler, you also need to create all the data and the databases for these component models. And there's one new tool on the go now, Data Map Creator. So this is generating the map data for compressors and pumps in exactly the right way how you want to use it in your TIL Modelica model then. And oftentimes you have little bit too little data or very little data, so you also get feedback whether the interpolation and extrapolation might work well enough. Yeah. Okay, now we zoom out a bit in the TLK toolchain. It's not only about TIL, but then you have the visualization tool Dave afterwards to look into diagrams and operation modes in detail. So you see just the state diagram here, but there's also animation of your system layout and stuff in there. And you can compare it to measurements directly in the tool. And I think there is not the one way to do the parameter calibration and the optimization. So there are multiple tools. There's the model fitter, which is an Excel add-in. So you take an FMU and optimize it in Excel, or there's an optimization suite, for example, for Python to do your optimizations there. And once your processes are perfectly and tidied up, then you can use mobile automation, which is more or less, you see these little icons here, like it's blocks of optimization of plugging together your simulation process. So I know at least 5 tools which do something like that. But mobile automation is interesting because it has a Python standard task library. So you see it's made from Modellicans. You have a Modelica standard library, and then you have your standard Python tasks, and you can connect them together. And it's graphically connected Python tasks, and you can write your own Python tasks in there. So it's a nice way how to make these Python automatizations available to engineers. Okay, now we move to this one little corner of TIL applications. We don't talk about heat pumps and stuff today, only about the hydrogen energy systems. And I also see a lot of Modelica libraries evolving here because there's such a buzz about hydrogen technology currently. And we see multiple application areas which sometimes you need to connect and sometimes you don't need to connect. For example, fuel cell systems, you see an airplane here. They just use the hydrogen, but on the other side, you need to produce it and store it. For storage, you have the very high pressures. So we use the vapor-liquid equilibrium approach from TIL, more or less. And then on the usage side, maybe you can use ideal gas assumption. So there are orange lines and not the green lines. You see, you pick your modeling according to your application. Now, one use case for the detailed fuel cell models are, of course, the Airbus Zero-E project. And there they do like quite dynamic stuff in start-stop scenarios and focus on degradation in the fuel cell packs. So I think that's quite detailed to someone just doing balance of plants in your hydrogen production, and you see in the models more or less where you also get a big benefit of Modelica that you can use detailed equations and move it to some other project if needed. Of course, there's also many kinds of electrolysis, and each week we have producers of electrolysis systems calling and asking Anne from my team or Toby from my team, okay, which library to buy? And then you have to look into details. And here's one example of PEM electrolysis. There will be a talk by Markus Pollard on Wednesday, 15 o'clock. So you can have a look there. It's not just the fuel cell system, but also the adsorption for purifying the hydrogen. So also the adsorption process is modeled there. Now moving from the PEM to the solid oxide electrolyzers. So you have these co-electrolysis processes now for syngas production. So in this case, we are producing methane. And I mean, there are many heat recuperation ideas and stuff, and you really see the benefit of having a thermal library as a basis and then adapting it to the various ideas customers come up with. Because we were benchmarked to other hydrogen simulation tools, and most of the time the result is no one has it ready because it's new technology, the models are not there. So you have to have a flexible basis and experienced people then building nice models for it. I said it's not clear where to move to. And so for Power-to-X, it's not completely clear where to go to. So if you go more on the process design side, methanol synthesis, methane, ammonia processes, there's also the process systems library, which is heavy, similar to TIL, but has more focus on the process engineering side. And you should talk to the guys from TLK here. André Thüring is here, Christian Schulz is here, Manuel Gräber is going to arrive. What is the right route to go and which equations to use for your process? Same thing, post-cap storage is coming back more or less to get all the to get all the carbon for your synthesized fuels. So this is also something which is modeled in process systems library. Okay, that's it. You got the faces of Christian Schulz and André Thüring. Now I switch to the last topic, and then I'm done with this slide bombardment. Just some recent developments in the DLR visualization tool library. So we're also partnering with DLR, but we just don't see so much multi-body movement in Modelica, unfortunately, right? So it's one part of our business, but the thermal people are much more coming to us. So visualization library, the interesting part of it is it's a Modelica library. So you put visualization components in your model and not some designer does some visualization afterwards, but really the engineer puts components in there. Of course, he needs input, and then you can have real-time visualization. Many Modelica tools are quite good in multi-body visualization, and you can use the same setup and the same visualization tool also for Simulink. So in projects where also Simulink people are around. There are some nice images from DLR, of course. Then you need to put it into your environment, and there you can now stream Google Earth data directly into your flight simulation. So that's a new feature. And still your Modelica model is behind it, and you're running the Modelica simulation. And then, of course, you need a human-machine interface if you do flight simulators or training simulators. And there's a nice feature that you can combine the 2D and the 3D view with data. So that's more approachable than to end users than using a Modelica tool. Still, it's based on the Modelica simulation. So if you change something in your model, it happens in the visualization, and you don't need to build code and bring it to a flight simulator or something. Okay, that's it. Thank you.